every piece of code has three properties. It can run to success, it can fail in between, and it may need dependencies. That is true for any piece of code. Now, it might require zero dependency, it might never fail and always succeed, but those three aspects are always critical elements of any piece of code. That's where effect focus.
Hey, welcome. This episode is my conversation with Ihar Arnaldi. He is the author of Effect.as, a functional programming library for TypeScript inspired by Zio from Scala World. He is also the creator of TS+, a new TypeScript superset language. In the conversation, we were exploring Effect.as, FPT.as, and the vision how both libraries are working towards unifying the ecosystem. We have also talked about why TS+ was created and what improvements it brings to TypeScript. I hope you will find useful insights from this conversation. And now, here's Ihar Arnaldi.
So you wanted to know how I came to the field, and the real answer is I never really chose to be an engineer. That kind of ended up being the natural extension of what I was doing. When I was around about 13 years old, my father bought the first computer that I've ever seen. And he kind of explained to me that the things I was seeing in the screen were not all pre-made and fixed, but you could actually program a computer to do whatever the hell you want. And that to a child sounds like a game. So that's actually how I started, for pure fun purposes, when I was 13 years old. And when I was going to school, I ended up by chance in a class where, talking with the professor of mathematics, he knew that there was a local company that needed a custom software, and they couldn't find anyone to actually build them the software at a cheaper price, and it was a small place, small company. And so he suggested to me, a 14-year-old kid, to go to this company and introduce myself, saying, look, professor sent me, and I think you need a software developer, and I want to try. And that ended up being the first commercial application that I shipped, which, by total surprise, it's still in usage today. That was like, I was 14, I'm 31, so calculate the time, was quite a long time ago. And that was kind of my intro to the field. Since then, I've been both studying and kind of working side by side, not in a very specific way. At some point after high school, I decided to try mathematics in university. Kind of did 3 years. At the third year, I realized, well, it's not that at the third year I realized, it's more that I never went to the university with the aim to kind of finish the university. I went to the university with the aim of learning whatever I needed, whatever I felt I needed. So I kind of done a little bit of mathematics, little bit of economics, a little bit of different things. And when I felt that I had enough kind of training by my standard, not by university standard, I dropped out, and I funded a company that was exploring the blockchain space. But it was like when I was 21 years old, 22 years old. So that's a long time ago. We were at the very beginning, and it wasn't even clear if the technology was useful to anything or not. So the company was kind of more a research type of company with potentially a product idea. That's how I left university and ended up being in the actual startup space, trying to build products. And given I was a founder, I was always in the positions to kind of deciding the technologies that had to be used. I was by all means not ready, and I could I always say at some point I should write a book, How to Fail with Unlimited Funding, because for my startup, I had unlimited funding. I had the co-founder of mine was, I'm not gonna share precise names, but he was a very wealthy individual that could fund pretty much any expense and had a network to potentially raise more funds in case it was necessary. So he kind of told me, like, you don't really have an upper bound. Please keep it as lean as possible. We don't want to throw away money, but money is here not so much of a problem. We have to be cheap, we have to be lean and mean, but if we have a product, if we have a way, if we know we can scale this thing, funding is not a problem. Well, we ended up failing anyway, which is kind of an interesting story. But that's how I ended up looking for what I would call highly productive technologies that can work in a small team, technologies that can lead to a large outcome with not so much complexity to deal with. Because when you are a startup, you don't really have large teams. You can't really afford to have too much complexity in a small system, because you don't have the team to bear this type of complexity. And functional programming is it's kind of a Swiss knife in the space, because it definitely allows you to do things better. At the time, the functional programming was at the very beginning of industry adoption, so there was nothing like today FPTS or these types of libraries.
You mean in TypeScript ecosystem, or like
in general,
broader,
in a broader,
in general?
yeah, in a broader sense, that company had a backend at the time running on a mixture of C++ and Golang, because it was blockchain driven, so it had a lot of hashing signatures and stuff like that required CPU intensive things. And at the time, TypeScript wasn't even here. TypeScript has turned 10 years old yesterday, actually. And the startup was older than 10 years. So TypeScript came around about half-life of that startup. And we adopted TypeScript because we realized it was a great technology since the very beginning, but it was kind of I would say embryonal. It was really early stage for the thing. The elements of functional programming that we were using were mostly around architecture in the backend, because at the end, functional programming is really about programming with data and pure functions. You can do that in multiple ways. You don't need to have extremely refined frameworks. You can still do it on a plain and normal language. It's harder. You can do less things, but still trying to follow the principle. And at the time, as I said, was very early stage on anything. Clearly, as I said, that startup kind of it didn't end up failing. We ended up putting the startup on hold because we realized the underlying technology, which is the blockchain, doesn't really solve any of the problems we were trying to solve with the technology. So we said, unless something major changes in the underlying technology, it doesn't really make sense to continue researching on that, because we were not able to solve any of the, well, we were able to build some prototypes, but any prototype we were building did not outperform in any sense the equivalent without using the blockchain technology. So that's actually where I kind of lost my my initial love for that type of technology and kind of moved on.
Yeah, I mean, blockchain is an interesting technology in terms of it trades off performance for kind of distribution, right? And there are, I guess, I mean, in my opinion, there are use cases where it works, but those use cases are usually very kind of limited, right? And even if I look at different projects which are currently active on blockchain, especially those that kind of it is interesting to see how different blockchain platforms start to move more towards decentralization to centralization. And the reason why they are doing this, it seems like they are doing this is because it is cheaper to run in with a more centralized database, right? And because there is no kind of, they are not selling themselves as the decentralized thing, right? They usually sell it as a smart contract or some other thing, and they try to compete with other platforms like this, similar. It tends to move more and more towards centralization and towards cheaper prices, because consumer at the end will choose the cheaper option, right?
The cheaper,
Unless
the
they are,
fastest, the
yes,
easier,
and it is much faster. That's true.
and also
Yes,
from the
and
consumer perspective, there is a huge safety risk in directly using blockchains. The idea that your keys are the unique access to your capital, your tokens, your assets is a double-edged sword. On one side, you are the only one having the keys. On the other side, if you lose the keys, you've lost. And that for a consumer is not a very good property to have. So any adoptable system will end up having a centralized way of storing the keys, which defeats the purpose of that type of.
I think it is the same thing. It is not like it doesn't work, like even like private keys, like not your keys, not your coin, right? The thing. I mean, it doesn't work for all the cases, right? If a person like 70 years old, they will not store their own keys because it will be gone.
But you should not, even if you have 20 years old. Because if you have anything of value there and you die the day after, nobody has access to your money. That's gone.
There are mechanisms, to my understanding, to do it in terms of like multi-sig and stuff like this. If you kind of die, and yeah, but I mean, as with everything in life and as with pretty much all technologies, there are use cases where when it could be used, and there are use cases where it doesn't really bring much benefit, right?
Yeah, but usually
And
from a consumer perspective, if you like use an Apple machine, you use a Windows, you use your smartphone, you use any piece of technology from a consumer perspective. You don't open Facebook and see built with C++, built with PHP. That's just the technology that is best fit for that purpose. You use the product.
yeah.
And in the blockchain space, the blockchain is always promoted as the reason why that is different. But from the consumer perspective, nobody is interested in how you actually implement something. You could, like, on the same level, you have the parallelism goes in programming languages. Nobody cares how you write your system if it works. Only you care how you write your system because it's easier to maintain it, and so on and so forth. So the functional programming, to my knowledge, beats the rest as a paradigm for productive things. But the consumer only care if this leads to better products at the end. It doesn't care about, yeah, you have a nice code base. What do I care?
Yeah, that I do agree with you here that most of the time, like, I think most of the time consumers care about end product, that they don't care about details. There are exceptions like this. For example, maybe there is a person who is deeply interested just in technologies and they kind of enjoy kind of figuring out what technologies you use, but those are rare cases. What I was trying to say with blockchain is that sometimes it seems like the actual product of a certain blockchain is that it gives kind of what this blockchain kind of sells, the value proposition, is the ability to control it, to have a higher control of whatever belongs to you, right? And some people want it. I think that the number of these people is smaller than in general, right? Those are like extremes in terms of distribution. But sometimes people want something that they have full control of it, and it is very common in when people live in a situation as, like, for example, in a situation where the environment in which they live is not stable, right? There is no trust that what is yours will stay yours, right? There are things like this. Again, I think
But
in some
I
use
see a
cases,
lot of
yeah,
properties. I mean, the ideas are nice. It's the implementation that
yes,
doesn't work. The idea of having granular control, censorship resistant
yeah,
technologies, non-reversibility of some parts
yeah,
of transactions, even though then I am a regulated person financially, so I I
sure,
have to say that mm, non-reversibility is kind of again a double-edged sword, because you might end up financing terrorism, you might end up financing things
sure,
that should not be financed. But all of those are principles that to some extent I agree with, and those are the reasons why I've looked in the technology in the first place. I'm not saying those use cases are not good use
yeah.
cases. I'm saying that the blockchain is not a good technology for those use cases, and we don't yet know what the technology is for those use cases.
I mean, even if we take those use cases, do you see like any use cases at all, at least like small part, for the blockchain to exist, like at all in
I see
principle?
use cases where a blockchain might exist. I don't see use cases where a global blockchain would exist. Like, I don't see the point of sharing the same blockchain infrastructure between different projects. There may be projects where you would want decentralization of consensus, but to
Huh.
achieve decentralization of consensus, you don't necessarily need an open network of potentially infinite peers. You need a distributed enough set of independent peers. So, like, if you want something decentralized, you could take 10 servers in Italy, 10 servers in United States, 10 servers in different parts of the world with different political interests that share absolutely nothing, no common goals, that run a single blockchain for a single use case, where they all agree that this specific issue is better if it works within this kind of distributed consensus. I think within a closed network, you might get, given you can impose limitations, like you can connect to blockchains from your laptop, but it's pretty unrealistic to think your laptop might be able to handle thousands and thousands of concurrent transactions per second on a specific domain. That's just unrealistic. 100 servers running in parallel in a distributed way it's realistic to think that we could get there by improving the technology. So I think there may be reasons for existence in the blockchain. I think there's, like, the technology is very early. Again, it's in its embryonal stage. I would compare it not even by the early days of internet, but like the very early days of computing. We don't really know yet how to use it, when to use it, which kind. It's at POC stage. Let's put it in this way. Uh, we have a very good POC that there exists a system where we can have fully decentralized consensus. We just need to find a good way to do so. It's like, for example, quantum computing. You have some examples of quantum computing, but still ages from the day where your laptop will run quantum computing, or even if your laptop will exist at the point where quantum computing becomes mainstream. Those technologies have decades and decades of figuring it out. And I think actually the initial idea of a single central currency as a mean of storage of wealth needs to be stable, doesn't need to fluctuate completely. It's actually a very good use case because we're seeing it even now that the economic environment worldwide is kind of in complete turmoil, and currencies are controlled, centralized by each of the government, and a government like UK kind of decides out of the blue to do a policy change and crashes the currency in a matter of a few days, making people lose 10% just like that. Then they change policy again. It goes back. Well, I do think there is if there were a single non-controllable sort of currency, that's not a good one to run economies. I would not run an economy on that, but kind of as a global safe haven, it might actually be a great use case, which was the original idea of bitcoins. So I think the most interesting aspect of those technologies, it's precisely on those aspects where now they've almost been dismissed, because it's only about, like, I've heard Bitcoin is a good way of making payments the first 3 years of existence of Bitcoin when everything was cheap. Now it's absolutely by no mean a good mean of payment. It's an expensive mean of payment. It's a slow mean of payment. You have instant transactions. So it kind of transitioned to be what people call it an inflation hedge. Well, we've seen that it's not an inflation hedge. It was a highly speculative asset that is highly correlated to the tech industry. If you check correlation between the prices of all the crypto assets and the prices of, for example, the Nasdaq, you find a high correlation, and neither are inflation resistant. That they're actually, if they are considered asset, they move with inflation. They raise price with inflation, and so on and so forth. And when central banks pull out money, those assets crash. And the most speculative assets are the ones that crash the most. So you see that both in the stock markets, you have the highly speculative companies such as the Robinhood, such as the, I don't know, all the SPACs, all the meme stocks, and everything else has crashed like 90%. Apple has not crashed 90%. Apple has crashed less because obviously it's less speculative. They're less risky, and they're more resistant. And Bitcoin, it's kind of an in between. It didn't crash 95% like some companies have, but it crashed way more than what, for example, Apple has lost in value, or things like that. So I think the whole model that it is blockchain today doesn't make any sense from both a macroeconomical perspective and from a software developer perspective. But I think, to answer your question, where you said, do you see any blockchain ever existing? Probably not in the way we think about it today, but I don't exclude that this wave of technology will lead to a different interpretation that may have positive outcomes.
Understood. That's actually interesting. And the way how you came basically to Bitcoin was through this company that you were all building, right?
Yeah.
So you got interested in blockchain, and it was like almost a decade.
Yeah, that was almost a decade ago, definitely.
Interesting. And the thing that, like, you said you started pretty much programming professionally since like 13 years old, right?
Yeah, I started professionally around about 14 years old. Started programming when I was 13, but I started writing the first commercial software when I was 14 years old, yeah.
And when you started working on this company of yours that you mentioned, and you were working on blockchain technologies, were you kind of using functional programming kind of aspects, or you started more like
As I said,
more
I
traditional
was
things?
at the end trying to organize the code in a functional way, but even that was very, very early stage. The set of technologies that we have today, and that I'm lucky enough to have participated in building partially, are at a completely different level. I when I talk about how we develop software, uh, how you develop today, or at least how some people are developing today, is fully different from what was possible 3 years ago, and it's 100% different from what was possible 10 years ago. On the other side, the kind of boring aspect is that the theory behind the technologies that we are building hasn't changed since the late 70s or 80s. The Well, I would say with small additions around 94, 95, with some papers from Eugene Omoji on using monets for for representing effects in Haskell. But those things are very old. Like we've only learned, I think, recently that they may be useful, but with kind of more a relaxed manner. And even in functional programming, there are different school of thoughts. There are people who like to do mathematics in a software development language. I think that's useful to some extent, but there are research languages that are targeting that specific use case, like, for example, Idris, Agda, Coq, Lean, and those languages that are really trying to stretch the boundaries of a type system to the point where if you compile your program, you're proving theorems, mathematically proving theorems. That to me, that I have a background in mathematics, is doing mathematics on a machine. It's the true essence. The true essence of mathematics is proving theorems. It's having ideas of a potential theorem, and you usually witness it in a few instances, and you say that might be a general behavior, and you then try to prove that general behavior through an abstract way that has to be logically a chain of logical conclusion derived from the axioms of mathematics. And by the way, there are different axiom sets where you can prove different things. There's not only a single mathematic. You change. I say mathematics is a game. It starts with a set of rules that are the axioms, and you derive from the axioms. You change the rules. You change the game. You're playing chess or you're playing box. It depends. But the mathematics is actually the process of derivation, the process of logical conclusion and proving, and the process of giving proof of what is absolutely true beyond any doubt, not beyond a reasonable doubt, beyond any doubt. If you have a mathematical proof of something, it's true. It's one of the only things where you can say 100% true or 100% false. There are paradoxes in mathematics, but there are a subset of things where if you can assert truthfulness, it's actually true or false. There's no fuzzy in between a thing that can be true or false. So if you want to do mathematics, that is the way of doing mathematics in a programming language. I don't think that's even remotely useful for application development. Some of the ideas may be ported in languages for software development, but you can't translate one-to-one. And that's where I believe part of functional programming is a dead end. It's never gonna get integrated in real life industrial production, and because they wanna go on the industry side, the language cannot evolve in a mathematical sense. So it's kind of stuck in between. What we are trying to do with libraries like FPTS or Effect, that's the one I've built. It's more getting the essence of some ideas and making it useful for day-to-day application development. Like, we don't really care. Effect is a monad, but we don't really care that Effect is a monad. Nobody even remotely cares that it is a monad at the end. Nobody cares that it has an applicative structure. Nobody cares about any of the mathematical principles. We might use it internally to have some guarantees, but at the API level, you see things that are concrete to the needs of everyday developers. So that's where I think that functional programming can win in a big time, because it's a principled way of doing things, and if you design it on the domain of app development without all of the jargon coming from mathematics, without focusing on the mathematical aspects, it can be extremely productive. And we've seen it even, like, if I think about React, one of the biggest revolutions in React was when Redux came out. Second big revolution of React was when hooks came out, when functional components came out. Those are all things that have kind of roots in different areas of functional programming. Not pure functional programming for the examples I've made at last. Actually, Redux, yes, from pure functional programming, but kind of hooks and functional component, they're not pure by any mean, but syntactically they are more declarative. Let's put it in this way, and all have represented big steps forward in usability of, and in how productive can you be when using a specific piece of tech. And we have the same with Effect. Like, I gave a presentation recently where I wrote the same thing in plain JavaScript, and then I wrote it with Effect, and was like 4 pages of code against 10 lines of code. And the 10 lines of code, you could add another line changing behavior again. You could add another line refining the whole thing. One side is perfectly, it's a pure description of what is supposed to happen. The other is an imperative way of managing state and everything else, where even making a small change, when you have 4 pages of code, if you make even a small change, it's very hard to be sure that the change is correct, to reassess the behavior, to even test it, and all of the things. So when you get to the point of shrinking complexity to something very, very simple that speaks about everyday needs, like managing databases, managing transactions, interruptible computations, concurrency, all of those things don't, the jargon is not mathematical. If you ever have built a backend, you probably had to interface with a database. If you ever built a frontend, you probably had to interface with APIs. If you call APIs, you have to control the concurrency. You have to control how many times you can retry if an operation fails. If you change page, you don't want all of the network requests that are ongoing to continue. You want to shut down the thing. So there are many things that are common needs that can be defined using very descriptive APIs, and I think that's where functional programming can make the difference. In other languages, the Effect is inspired by Zio in Scala, which is trying to do the same thing in the Scala language, kind of clean up the mathematical aspects of functional programming, all the jargon, and try to find a concrete core that is useful for the developers. And I think they are doing an amazing job. We're trying to do the same type of job, and the beautiful thing that I'm extremely happy about is that with the fact that at the beginning we depended on FPTS, but then we branched off. And we branched off because FPTS was very mathematical. The author described it as a way to teach mathematics in his view. And that posed limitations that with effect we tried to change. So we took separated roads, but recently we are working again together to try to build a single ecosystem by bringing back the learnings that we had while branching off with effect into FPTS 3.0, which will take most of the naming conventions from effect, which will take the basic behavior of unifying types and embrace the variance of the language, because TypeScript is a structural language with subtyping. Haskell is a nominal language without subtyping. So they're different host language. What you can do by leveraging at the maximum your language is more than what you can do by simply trying to copy over the patterns. And the progress is fantastic. So I'm more and more confident that we will get to a point where we have a single unified ecosystem of libraries where it basically become a very large set of Lego blocks that you can compose together however you want in your program with familiar syntax. So you don't need to have a degree in mathematics to read the library code, to understand it, to use it. You can even start as a junior.
Few things. First of all, I would be happy to see what FPTS 3.0 would bring. I'm more familiar with their ecosystem, and this is why I'm more excited. To be honest, I started looking into effects, right? And I just didn't know it existed before, not long ago, and this is why I didn't have the. And hopefully, this what we record right now also will help other people to kind of find out that such a thing exists, right? But in terms of not knowing mathematics, I can say, at least personally for me, when I started to look into FPTS, as you know, the documentation in terms of examples is very sparse there. It is more about like type signature, and we kind of assume that you should know. It was difficult for me even when I was starting, and still is right now, but less so, but still in some scenarios and use cases. But it was difficult, and this is one of the reasons why I wanted to kind of maybe I thought about how can I help, right, in terms of taking all these things that I also find useful, not just because in the conceptual mathematical sense, but because they help me to solve actual real life problems in a better way. And I will talk about this as well. So I thought about how I can do that. And there is like a project that I'm working on in terms of like educational materials and stuff like this, right? But for me personally, for example, when I was starting, first of all, it is interesting to notice, for example, how in the last, let's say, 5 years, many programming languages in general across our industry started to adopt more and more bring some pieces of functional programming, right? to them. It is like even when Java started with Java 1.8, started bringing Lambda functions and stuff like this, it was interesting for me over the course of the last couple of years to see how the whole industry evolves and moving toward that. And this was interesting for me because I started to be interested in functional programming myself not much earlier than this started to happen. Maybe like 7 years ago, I started to be interested. I somehow kind of started piece by piece encounter different things which sounded reasonable to me. And I even remember that I was giving some one tech talk in my home country where I was born about, and I was doing it along with a different person. He was talking about object-oriented approach to things, and I was talking about functional approach to things, right? And this is where I was kind of digging deep and finding out that it kind of started with Alfonso Church and with his like Lambda proposition, right? And how they work it with Turing. It was interesting. And since then, I was still interested in those ideas, but the problem is that I couldn't really know how to apply it to real life, to actual problems that I have. Yeah, I knew that Haskell was there. It was purely functional thing, and like I could spend a lot of time kind of digging deep into it, but at the end, it will be good for me, for my kind of satisfaction, basically my own, right?
You know that there is a joke about that. Haskell is pure because nobody ever runs it.
Yeah.
The code itself is a pure description.
I mean,
that is a dark joke. It's a very useful language to some extent, but I understand your point of view. It's useful for you to learn, but you can't apply it.
And this is why FPTS was, I first encountered FPTS, I guess, like 4 years ago, something like this. And this was kind of a breaking point for me because it gave me opportunity to use these things that I found interesting and to solve actual problems that I actually have, right?
You could use
and
it.
This was a very critical. Yes. It took me a while to start to even understand. You can understand general concept, but with all this knowledge, when you come to a project and you want to start writing an API endpoint, actual API endpoint with all those things that you mentioned and even more, you kind of, okay, how do I do that? And it took me a while and a lot of kind of rewriting and experimenting, but it was very transformative for me, and I find it very useful. And again, there will be like much more like to go. And the interesting thing about functional programming for me is that it gives me confidence in what I'm doing, right? If I write something, I write and I know that it works instead of thinking that it works, right?
Well, I would add, because it works in a specific way. You know that the defined types, like if you use task hider, you know that program is asynchronous, you know things about the execution, and by looking at the code, you have a pure description. The power is then limited by obviously what the modules can provide, like building what you described before, like a backend with APIs and so on and so forth. It's still very difficult by using plain FPTS, because yes, you have nice modules, but you lack a solution for connecting to databases, to manage resources, the life cycle of a resource, which is something you acquire, then your program runs, and then it cleans up. Dependency injection, many of the patterns that are familiar for, like, if you use Java and Spring in an object-oriented world, dependency injection is figured out. error management is and logging of errors is figured out. You might argue in bad ways, and I would agree with that. But by using plain FPTS, you don't have anything close to that. You have to reinvent a lot, which is where
Yes,
the
you need to build it
complexity comes
yourself pretty
in.
much.
You need to build it yourself pretty much. And that's where
Yes,
effect
yes.
breaches a little bit. Because effect has dependency injection built in. Effect has interruptibility. It's based on fibers, so it handles concurrency very well. I would say it's more concrete than FPTS. While FPTS provides the abstractions, uh, effect provides the concrete implementations. And at the moment, we had these two independent ecosystems where we also had to care about abstractions in effect because the abstractions in FPTS were not powerful enough. But in FPTS 3, the abstractions will be powerful enough. So we will be able to depend from effect, in effect, to depend from FPTS and export the same abstractions that FPTS is using. So that we have this more common an ecosystem that works together instead of working against. Because really what FPTS does, it's a very abstract library. And then you have concrete modules. And the funny thing is that most of the people use it for the concrete part because it has modules to interoperate with arrays, iders, options, promises, and stuff like that. But it doesn't build anything that is not already in JavaScript. The task module is a wrapper around promise. It's limited by what promise can do. Effect goes way deeper, and we don't use promises in effect. Effect is not a wrapper around promise. It has its own runtime that is a fiber system, and it provides way more concrete value. It would be it will be extremely interesting to see when the two ecosystems merge, not merge in the same project, but merge in a way that they are interoperable with each other, that effect compounds FPTS and FPTS compounds effect. It will be really nice to see where this leads.
You can correct me if I'm wrong, because I'm trying to wrap my head around all of that, but my understanding, the way how I conceptualize it in my head right now, is that FPTS provide a set of structures, right, which are more like fundamental and more theoretical, let's say, I don't know.
To some extent.
And effect provide kind of is a layer on top of it, which kind of bridges what the concept that are inside of FPTS to the more real life use cases.
To some extent, yes. Yes, to some extent, absolutely yes. And that is also why I think it's important to keep the libraries to some extent separated, because you might need just a simple wrapper around a promise to make a small piece of front-end code look better. You might not need all the power of a fiber-based runtime system. But to build something like a backend where you have databases, where you have complex architectures, or even if you want to use functional programming in the large in a front end, you benefit a lot from effect. But if the two systems are progressively, like, you can't start with basic FPTS and include the effect whenever you need it. You can start easy. You can start very simple, and you have a path forward, which is learning bit by bit. You start, you include a module like task from FPTS, and then you ask yourself, okay, how do I interrupt this operation? Oh, I can't. To interrupt it, I would need effect. Let me import effect. The same code will work. You just have to change basically the import effect instead of task, and you would get it with interruptibility and other constraints that are closer to your needs. But you learn things bit by bit. It's not a full in.
I think it, I could be wrong here for sure, but I think different people, what I have experienced in my life is that different people learn in different ways, because it seems like some people want to kind of start learning from bottom up, right? They start from understanding each piece in particular, and then they kind of build up to be able to build something useful, right? But other people, they kind of, let's say, use some library, they solve a particular problem, and only once the problem is solved, they kind of try to dig deeper into how this library works and to kind of explore it. So I'm not sure, of course it is speculation on my part, but if my conceptualization of how kind of FPTS and effect relate to each other, I would assume that most people would start to get familiar with functional programming ecosystem with effect first, because it provides tools to solve their actual needs. And then when they see that they can solve their actual problems fairly quickly, and they notice that the way how they solve it is more efficient than how they used to do it, then they will try to dig into effect, and later into whatever is even more fundamental, to understand like why it is the case, why does it happen like this. Because for me, when I was starting functional programming, what I noticed is that I was writing more code, just in terms of lines, right? And I thought like, it should be better. Functional programming should be better, but I'm writing too much code. And it took me a while to realize that the reason why I'm writing more code is because those concepts kind of force me to handle edge cases. Because in my previous life, what I was writing code for the happy path, and of course it was smaller in terms of code, but like it doesn't work that well because happy path is not.
But I believe that you have said something beautiful, and I believe the true objective of functional programming is for you to program not in the same way, but in the same amount of code as only caring about the happy path, while also caring about the edge cases, while also caring about the stability. I think that is the final objective. We are not there yet. Still a little bit more verbose, but if you use effect, you already see that the code starts to shrink, because many of the things are already in the library, and you can just reuse the building blocks, and that kind of compacted a little bit more. Because the true objective is you should care almost about only the happy path, but be notified about when you have an edge case. And by notified, I mean having errors explicit, and decide when you want to handle the errors, how can you handle the errors, and all of this machinery. The other aspects are the dependency. I say, and every piece of code has three properties. It can run to success, it can fail in between, and it may need dependencies. That is true for any piece of code. Now, it might require zero dependency, it might never fail and always succeed, but those three aspects are always critical elements of any piece of code. That's where effect focus. Effect has three types, three generic parameters that represent the dependencies that your application needs, the errors that your application may produce, and the output that your application will return in case of success. Those three concepts that to me are fundamental in any piece of code are represented at the type level with an API that doesn't make it complex to maintain all of these types. My personal objective is to get effect to the point where you write code without even typing. There are people who like all types explicitly annotated, and
You mean using like kind of suggestions
no, I mean inference,
in?
complete inference. If you write a function and the return type is inferred, you don't need to write it. Writing it might be useful in some cases, but might be counterproductive in other cases. And
I think in terms of maybe I'm like not completely understand what you mean, but when people write functions, right? It's kind of common, I think, to kind of think about what kind of arguments you accept and what their types would be and what would be the expected return type, right? And when you do that, then you can kind of write the body of the function, and if you declare the types in advance, the compiler will tell you if your body doesn't match what you kind of stated it should be, right? And this is why my understanding people like to write type declarations for the functions explicitly, right? Because even in TypeScript right now, you can create a function and not specify even arguments type and return type. You can do that, and you can do it. It will still be functional programming, like match all of these things. But and I'm not sure, to be honest, if it is possible. Maybe I don't know if it is possible to kind of declare functions without declaring their types of arguments or the return value.
Well, the arguments always need explicit typing because those are the inputs to your program. But as of the return types, there are two schools of thoughts, even in extreme functional programming. There is the school of thoughts where the compiler is a checker. So you specify what you want, and the compiler will check the body to ensure that what you stated is actually respected. And there is the second school of thought that perceives the compiler as a friend, where you have interactivity with the compiler. If I write the function input, or the function arguments typed, and I write the function body, the compiler tells me what is the return type. There is an interactivity between me and the compiler. I don't think either of the two are fine for 100% of the cases. I think there is blurring in between. Because if you think about, for example, a program, and you think about adding one more error case to a specific function, you don't really want to go and change all the type signatures of your program to also carry that specific error type. You want that to be completely inferred. Only where you care that you have handled all of the errors, you actually want an explicit type to be sure that at that point, it's powerful to express boundaries, but it's powerful to relax the boundaries where you want more interactivity with the compiler. So both school of thoughts are positive in some sense, but the objective should be that you can do both in a non-verbose way and in an extremely productive way. Then the degree of which everybody has their own preference, I don't really care. And my code looks, in a way, your code might look slightly different. If we're both highly productive and effective in what we do, fine. And I don't want to tell people how their code should look like. I want to give tools to people to write better code. That's the objective, at least to me. And I'm very happy to see that now we are finally converging with FPTS. Most of what we've extended from effect is getting back to FPTS. As even names of functions like there, if you have a function that for example you want to use to log errors and stuff like this, chain first is an awful name for that function. It doesn't have any meaning. Tap error is a way better name to understand that this function taps onto the error of the program you're using. That's the same function, just with a different name, and it makes a whole lot of difference for the consumer of an API. And FPTS is getting there too.
I think, I mean, in terms of naming, because yeah, in terms of kind of things like, people sometimes say that one approach is more readable than another, or more maintainable than another, or one name is more clear than another. And to be honest, I always struggled to understand how people kind of know, right? Because for me, it always seemed that what is more clear for one person could be not as clear for the other, and mostly it depends on where those two people come from, what their background is, right? Because if we, for example, talk about some, person which has a very mathematical background and which comes from even like, so which comes from a different background than most people, let's say, then I couldn't imagine that there are people for whom chain first would be kind of obvious name, right? I would say that maybe the number of such people is lower, right, in general, because I think the higher amount of engineers who are doing like regular engineering work, and they will be coming from the backgrounds of like regular JavaScript, regular Java, whatever. For them, what you're saying will be much more clear, right? But I would assume that if some person comes from, I don't know, Haskell and tries to write in TypeScript, I would imagine that they would feel comfortable with chain first. Who knows, right? It's just like my
that is true, of
it.
course. If you borrow names from a different language, the people coming from that specific language will be more familiar with it. That's normal because they are used to write in that specific way. But one should ask, when it's about naming, the best name is the name that is closest to the concept you're trying to model. If you have a computation that produces errors, first and error have nothing meaningful. First doesn't mean error. Now, chain first might be a general name in the abstract sense, but in a concrete module, if that module deals with dependencies, errors, and success, it's better for the success function to be called success, the error function to be called error, and the dependency function called dependency.
Yeah.
Because they directly map to the concept for any new person learning, if you think about error or failures, now you could then argue, okay, which one is precisely better between two names that have similar meanings? Fine, but some things are pure constructs, and like that is where actually there is one interesting point, and some people perceive Haskell as the absolute truth. But Haskell is one interpretation of category theory wrote in a language. Haskell calls functor what in reality is a covariant functor. Haskell calls applicative something that doesn't exist in mathematics in the same way. The closest thing would be monoidal. If you simply look at the mathematical structure, nobody's caring about applicative structures in mathematics. That is something that was useful in Haskell because Haskell is curried. In TypeScript that is not curried, generally, you don't write functions in a you have multiple arguments functions. It's not that every argument is a different. Um, like in Haskell, you have two mathematical functions. You have one argument that returns a function that returns a function that returns a function. In that sense, applicative makes sense because it's the progressive application to that curried function. Inside Haskell, that has a meaning. Inside TypeScript, Scala, and more object-oriented languages, a different representation might be more natural that has the same mathematical properties. Monoidal and applicative are isomorphic. One can be derived from the other, but one is better fit for things like TypeScript or non-curried languages. Now, not to go into many details, but the point is, again, mathematics is not there. It's not a single thing. There exists multiple mathematics depending on the rule set. The rules we have in TypeScript, the rules they have in Scala, the rules that are in Haskell are fundamentally different. And the best you can do has to account for the differences. Because otherwise you are restricted to the minimum that is common between the languages. Where you really want is to maximize what you can do in your language and to maximize what you can do in the other language. So I think for Haskell purposes, some of the naming, some of the conventions are perfect. When translated to a different place, the perfection starts to crumble because we're not running on the same set of rules. So we're effectively playing a different game. And if the game is different, then what's optimal is different. And I'm not saying we have the perfect solution right now, but we are trending towards that. And another thing that you said that is very correct, you have to look at numbers. If there are 10 people who are familiar with A and 100,000 that are familiar with B, probably you have to care about B. And the 10 can adapt. If you know Haskell, you can work even with slightly different names. Concepts are similar and so on and so forth. But if you don't know Haskell, you shouldn't learn Haskell before you are able to use FPTS. You should just be able to learn FPTS and use it directly.
That is true, because you kind of, as I said, you kind of expected to know a lot of these things to use FPGAs, right? And it is also interesting because if we are talking about such layered approach, right, we have like FPTS and on top of it we have FXTS. When people, it is also kind of important to know at which level of abstraction the person will interact, and again, different names could make sense at different levels of abstraction, right? And FXTS that tries to bridge the gap in order to allow people to do actual production, like common things that we do in production, right? Yes, I totally agree that there we need the names that are more common to what the people are used in this kind of domain, right? It is much more beneficial than an abstract thing which uses that FPTS use. But at FPTS level, right, since it is kind of more at a lower level of abstraction, then more kind of abstract name makes sense there, because it is. And there could be cases
even there,
when,
in FPTS, yes, you have two things. You have the abstract side, which are the type classes, and the concrete side, which are the modules, like array, like set, like either, like option, and so on and so forth. So there is a concrete part in FPTS too. Now, one very interesting case was a discussion we had recently about the naming of traverse. Now, I think traverse array is an awful name. I think for each is way more clear because you have an array of things and you want to run an operation for each element of the array. But for each is a terrible name to use in general because given different structures, the operation is slightly different. So traverse is a better name for the type classes aspect of FPTS, for the abstract aspect of FPTS. But in the task either module, you should have a for each function. You should not have a traverse array function. That is where the name specializes to the specific concrete case. You have a generic principle, and that specializes to a specific one in a specific case. So the two levels of abstractions that you also described is important. So if we're talking about blocks, I think there are actually three blocks. There is the abstract side of FPTS that is composed of type classes and functions that operates on the type classes. There, I think the classical names are better, like their functor monads, applicatives, and so on and so forth, are more knowledgeable, are known from a lot more people that wants to deal with that level of abstraction. And if you want to deal with that level of abstraction, you're even better using the same names because the whole documentation's online, the references that you will find use those names. Then there is the concrete side of FPTS. There are common modules that are basically shells around basic JavaScript primitives, like set, like array, like promise, and so on and so forth. Very common things that you might want to use in pretty much any application. That should have naming and behavior, which is familiar to the user, and then effect that builds on top, which is the more concrete aspect of application development with functional programming. Like this abstract is JS proxies, not proxies in terms of like JavaScript proxies, but a functional proxy to a JavaScript primitive. And then there is effect, which is concrete for application development, specific in application development. And the naming, as you said, at the lowest level, it might make sense to keep the broader name, but as we go above, we are closer and closer to everyday needs of developers. So we should be more familiar with the consumer, because that leads back to the beginning of the discussion. If you talk about products, consumers are interested in using the product efficiently. They don't really care that those modules are built using mathematical principles. They care that from those modules they can build nice software, and that this software is understandable for the majority of people. And I can guarantee to you, if you take anybody and a function is called tap error, they might not know what tap is, but they probably guess has something to do with errors. That is the first guess. Contains error in the name.
mean, that's...
If you see something like chain first, they have to know that chain first means I want to tap onto the error channel.
But with chain first, it is also interesting because you could use like whatever. Let's say it is common to use, let's say, either when you have first error and then you have your result, right? But there is nothing prevents you to use like a different order if you have some specific use case, right? You can do that, right? It is not common, but you can do that.
But pay attention,
And for this
because
reason,
it is
yeah,
possible, but it's not the interpretation of, because either is yes, either left or right, but the functor instance of either is pointed on the right side. So the meaning on the type class instances and everything else, it's not the same. You can't just flip it. And you can flip
it's
and,
true.
and jump on the other. You could say, okay, I have an either, I flip the either, I'm up, and I flip back. That is a map on the left.
I guess this is my point, that lower you go in terms of abstractions, more control you have, but you also need to deal with more like kind of abstract concept and abstract names, right? And this is kind of why and people, I do think that most people who do production work at companies different, let's say they use something like Lodash, right? They just use it and that's it. I don't think that a lot of people really go and look into how it is implemented in terms of structures, in terms of optimization. But they are users in this case. They just use it and it works. Some of them are interested enough to kind of dig deeper and understand and learn. But I would say I would assume, I don't know, but this would be like a smaller amount of people, right? And kind of for those people, kind of, they need to understand what they sign up for when they try to expand their knowledge in general, that they will realize that sometimes people use a lot of different names for the same thing, and it is very, very interesting in terms of how, and not even like different things, it is also, when people try to learn deeper and deeper, they also need to know kind of the history, how the things happened because of the history, right? And how it affected for legacy reasons, right? Because some things that we have, even in JavaScript, make no sense right now, but they are there because this is how it happened, right? And it is just like, a sacrifice you need to do if you want to kind of increase your general understanding with the tools and stuff like this. But for me personally, I would say that yeah, I had to go through all this experience, but trying to kind of extend knowledge, right? But I found it very useful for me to really know in details the tools that I use, right? Because you can use even, let's say, the simple thing. Even let's take VS Code, just a tool. You can download it, open, type. It works, right? But if you invest time into understanding how to kind of configure it that it works the best for you, I believe that you have the opportunity to increase your productivity in general multiple folds, right? And this is with every tool pretty much, right? For example, I use a lot React Native as well. You can go and start like create React Native app. It will create you scaffold. You can start typing and it works, right? But if you want to be able to do very specific things that you want to do, you kind of need to know the specifics of how to implement it, how it works, and stuff like this. You don't have to know it to use it, but if you know, first of all, you will be more productive in general, and second, you will be able to control more granularly the results of your work. Maybe it is like 2%, right? But you will be able to build a product which is 2% than products on average, right? And this is why I find it so useful to understand in depth really tools that you use. This is how it is, I guess.
Yeah, no, that is
like
but that is a very correct interpretation, because there are different types of people. I'm also of the kind that I like to know my tools very well. I'm not really a fanatic of text editors, IDEs. I kind of use kind of the basic configuration is a good fit for me, but not because I don't want to. I have not spent the time. It's just because when I started programming, I was using text files with no coloring. There was nothing at the time. So to me, even what a basic editor does, it's way more than what I need to be productive. And I mostly concentrate on the coding aspects. But one concept I try to say a lot is don't use a library that you wouldn't be able to contribute to, that you wouldn't be able to understand, that you wouldn't be able to, like, you don't have to contribute huge features. Absolutely not. You don't have to digest the whole complexity. Absolutely not. But know your way around the code of what you're using. Because otherwise you're really, really, really buying into unknown, into complete, sometimes complete madness in TypeScript. Because you have the full NPM ecosystem at your disposal. There's crazy stuff there.
I mean, let's take React, right? The amount of people who use React in the world is like huge.
Yeah.
How many of those people can actually contribute even small features to React code base? I don't think it is very big a set of people.
Yeah, and there are a lot of people using React for things they should never use React for. There are a lot of people that don't understand React by any meaning, and we've seen it even recently when in React there was the V18 update where concurrent mode finally made it through.
Yeah.
And for concurrent mode to run, well, turns out components need to be pure because mounting and unmounting could run multiple times, even on a single render, because you might have things suspending and so on and so forth. So React added a check in strict mode for development, which basically forces every use effect to run twice. That's just to prevent people from having bugs derived from the fact that use effect may run concurrently if you use concurrent mode. That made people crazy. That made people go completely insane. Well, it was obvious from day one that you should not perform side effects in the use effect. That is there for synchronizing between UI and state of the world, knowing that a specific component has mounted or has unmounted, and stuff like that. That there are rendering effect running on that. Now, obviously, you don't contributing to React. Now it's a project to a point where what's left to do are complex things. So you can't pretend people open such a complex code base and go straight in and know their way. But knowing how it works in details is fundamental to use it. Because otherwise, I think the average user of React will have issues updating to V18 at the moment, just because the total lack of knowledge and the total madness of wanting to manage the state fully inside the rendering cycle of something. That React made it clear from day one that was not supposed to be the case. But as you said, there are, I think, millions of people using React, and probably those millions have most likely no idea about how it works in the internals.
I mean, from my point of view, like, I mean, I guess even if there is a lot of people who don't use React, properly, correctly as per book, let's say, right? They still use it and they still create final product that kind of works. Yes, it could work much better, right? Much better. If you look at the web pages and when you take your phone and it is like hot because it just loads some page, it's horrible. But I mean, it's better that we have this page at least than not having it at all, right? for me personally, it would be difficult to work with people who don't understand in details the tools, because I will find it myself explaining all the time and spending too much time and not kind of being very productive. And it is just my personality that I want to be productive, and for this reason it would be difficult for me. But at the whole, I would say that it is a good thing that even if those applications could be much better, it is better that they exist than not. Let's say we have some government website. Yes, those government websites are horrible, but it is better if you can use them rather than going in person and waiting in line.
Till the point where they leak your documents.
Yeah.
When they leak your documents, then you're back to thinking, oh crap, they are government's website, they should be as secure as possible. The problem is everything is right till shit happens. Now, I think React is by no means that high risk, and it's well maintained enough where it's one of the only cases where I would say it's positive that people are using it no matter the deep knowledge. It's trusted enough code base and it's documented enough for you to be able to use it without deep knowledge. You might find yourself in some edge cases where when you face the edge cases, you go deeper. So for that specific one, I would agree with you. But like a database library, if you just use it, do you know if it escapes properly strings?
Yeah.
Or not.
Yes.
Stuff like that. It's fundamental to know. Now, you might rely on documentation 100%, and then the libraries you can use are the 0.000%, because there's a huge investment to have a documentation precisely reflecting all of the behavior of the code and have all the language to explain the detail of the behavior of the code. Now, a language like TypeScript doesn't have everything documented. Even a Microsoft project with that level of investment doesn't have everything documented. So knowing your way in code is fundamental. And many people have the perceptions that libraries are magic. Libraries are written precisely in the same code that you use for app development. If you look in FPTS, 99% of the things you see in FPTS are plain and normal functions that you could use in your app development every day. So it is not impossible to understand it by going through the code. I don't suggest learning it going through the code. That's not a good way of learning. But once you've learned the basic, once you get your prototypes working, once you are deciding if you really should use that technology, open the source code, have a look at the source code, look at the style, look if it's well maintained, know your way around it. You don't have to be at the point of being able to do major feature contributions, but you shouldn't be scared of saying, okay, I have a bug, at least I realize where it is, or like that turns the other way too, because many times you get bug reports without any type of reproduction and just a little description of the behavior. You're not gonna get bugs fixed if you report issues in these ways, because the maintainers will not be able to reproduce your issues, and if the maintainers are not able to reproduce your issues, you've got zero chances of having a bug fixed. The only chance is the maintainer also realized the problem, has a reproduction by themselves, and they managed to fix the bug. While it would be way better if the user spent enough time to produce a proper reproduction, a minimized reproduction that focuses on the precise issue. That takes time. It's a lot of work to do as a user of a library. That gets bugs fixed. That is contribution. contribution doesn't need to be hard contribution. Opening an issue with a proper reproduction and a proper description of the behavior is already a huge contribution that you can do to the open source as a consumer of something to solve problems you found. At this level, I think everyone should get at this level. Because if I notice a bug in React, if I'm not able to scope it down, if I don't understand where it comes from, really there's no way to prove if it's my bug, if it's React's bug, if it's misunderstanding or anything else. And you can see like the more the libraries becomes popular, the more amount of issues just gets completely ignored because they're meaningless. They're meaningful temporarily for the person who opened the issue, and then either they find a workaround or I don't know how they can continue. Like it never existed. I've never opened an issue in my life without providing enough details or without explicitly saying, folks, I have absolutely no idea how to do this. Would some of the maintainer be available to help me scope it down? I can do a lot of work, but I need pointers. If I don't know where to go, I need some pointers. But that's a positive interaction. You're not saying just, I have this bug, I don't care, you fix it. No, I'm interested to fix my bug. So if I don't have any idea where to look, I may ask to maintainer a little bit of help. That's even how you learn deeper. Because, for example, I had recently a bug in vtest, and I knew zero about the code base of vtest. I started using before knowing anything about the code base of vtest. And I had a bug. And I was like, how do I proceed? I had absolutely no idea where to look at. Well, you start, you clone the code base, you spend half a day on it. After half a day, you start to get an idea about where things are. The day after, I opened up an issue with a proper description of the bug, contacted the maintenance. The maintenance had no bandwidth to solve it. I asked, would you mind if I make an attempt? Sure, go ahead. Made an attempt. Another bug generated from my attempt to fix it, fixed the other bug, and now the fix has been merged and it's in production. I knew nothing about that code base before starting. But if you're not at the point of, you have to either know you can dig in, or you're simply blindly trusting. And blindly trusting Facebook, it's kind of okay. Blindly trusting Microsoft is kind of okay. Blindly trusting any maintainer on NPM, it's by no means okay. Like if you use React without knowing anything, fine. If you install a casual library from NPM without knowing anything, you might end up in strange, weird places. And you might expose your users to risk, leak of data, and so on and so forth.
I mean, as a person who uses, right, as those developers who use it, I guess it all comes down to how invested you are as a person in having a good result, right? Because people have different motivations for their job on why they do their job, right? And for those people who actually very conscientious in terms of the result, and they care about the result, and they want to have the good result, even if they, because we all started using libraries at some point without knowing them, right? But if the person actually wants to get a good result, then yes, they will find it interesting to investigate the code base of the libraries that they use. Maybe not all and not at one time, right? It will take time to progressively run on this. But there are also, I think there are also people who kind of just have a ticket at their job and they want the ticket to go away.
Yeah, but I think it's totally dependent about what you're doing. If what you're doing
Yeah.
is something that doesn't take any personal data of your users, that doesn't expose any higher risk, I think it's totally fine to build your personal website, your personal blog.
Yeah.
You don't need all of the detailed work.
Yeah,
But
sure.
before you made an example about a government website, for a government website where you put your documents in, uh, not having the level of knowledge that allows you to explore the code that you're depending on is a high security risk. It's not a low security risk. So in that case, I don't care that the person wants the ticket gets closed. The ticket has to be closed in a proper manner. So it depends totally
Yeah, I mean,
by what by well I would have to say by the risk level of the target you're trying to develop for.
that is true. You understand this and you kind of have a reasonable assessment of it, and that is good, right? But it depends on whether in their organization, even if it is government organization, whether there are people like yourself who understand the level of importance of what they are doing, right? And it could be or could not be the case, right? And it is unfortunate, but it is reality,
Yeah,
right?
yeah,
And
it's
this is,
absolute reality. But it's also why we
yeah,
optimize the APIs to the point of allowing that. The fact that, for example, Effect has not yet reached 1.0, it will reach RC1 close, like next 15 days, and will probably reach 1.0 by the end of the year. My focus will be to make it as dumb as possible for users to use it without knowing the low level of effect. That's totally fine. And I do expect 99.9% of the people starting there. But I still suggest, as an advice to the developers I mentor, if you really want to get to the next level, to the next stage of your career, you need to dig deeper in the things you're using, because there are many people who like have used React since 7 years, since the very beginning, and are perfectly fluent in React. They've done only that in 7 years. They have not. They are not more valuable today than they were 7 years ago. They were actually less valuable because the number of people knowing React went way up. So the higher your knowledge is in a specific topic, the more valuable you become. If everybody knows React, knowing React is not a game changer. If everybody knows React, but only 3% know how it actually works, well, that 3% has way more value. So that is more of an advice to the developers that I give in general. But I do realize that the reality exists and that most of the developers will not take that approach.
yeah. And it is interesting. I always found it myself kind of. I found a lot of value in building my own bicycles, basically. And even if the tools exist, the problem is that I wasn't doing it properly at the beginning, right? Because I was trying to build bicycles on actual production projects, which is not a good idea usually, right? But in general, when you have like some, experimental project and you building bicycles there, I found it very useful because if you try to kind of implement from scratch React yourself, yes, you will not get it to production grade level.
You will not build
you don't need
React,
to.
but you will understand way more about React than anybody else.
Yeah, and it is very beneficial was to understand how the things kind of to understand how the people came to the point that the React looks the way it does, right? And it is very, very helpful for me, Ben. And even like in FPTS, I was using it for a while, more or less. It was doing the thing I wanted, but a huge progress for me in terms of understanding this was when I tried to re-implement. They have the routing library, I think it is FPTS route or something like this, for API endpoints, right? And it didn't kind of did what I wanted exactly, so I ended up building the thing myself. And I do eventually plan to switch to using their version, because now it does what I need, and it is better if I use something that other people use as well. But the experience itself, for me, building it from scratch, I learned a lot, and it kind of clicked much more than it was before, and this is why I find it very, very
And
beneficial.
I think after having tried to build your own prototype of that, you would probably be able to contribute something even to the original library if needed to.
Yeah.
I'm not saying you have to,
Yes,
but if you
yes.
need to, if you have a bug and nobody else is interested in solving that bug, because of course open source might also mean that the author doesn't give a fuck about your bug. And sometimes that happens even in large projects, especially if they are linked to a single company in maintenance. Because if it fits the company need, if it works for the company, it might be buggy for everybody else, but the company is fine. They're not gonna prioritize bug fixing for your thing. If you can do it yourself, you are way ahead, because you no longer have limits in saying, yeah, okay, fine, I can even fork the project. Might not be the best idea to do. Like you said, I've built mine, then I realized progressively that the original one has implemented the features that I need. It's better to have one instead of two independent things, like we are, for example, doing between Effect and FPTS. Instead of having Effect re-exporting and redoing all of the type classes and all of the stuff, if FPTS gets to the point of being abstract enough to represent the things that we have in Effect, then better to use FPTS for those. There's no point whatsoever duplicating the ecosystem for everybody. It's way better if it's a single conglomerated solution that everybody uses instead of 500 different minor interpretations. But that is possible only because people such as yourself end up building their own, branching off, trying on a personal project, fucking things up 5 or 6 times, learning, and getting to the point of, yeah, okay, I found a better solution. I want to get back that better solution to the ecosystem, or it's so fundamentally different that it deserves its own existence. Because not every time you can go back. Like in FPTS2, there would be no way to export effect instances using FPTS2. It's too limited. It's literally possible. But if in 3 it becomes possible, and I'm pretty sure now that it's gonna become possible, then way better to build one instead of two. But there are cases where you cannot do so, and there are cases where the new library takes over, and it's a complete fork. Now there are not
Yes,
many projects. Like if you think even Linux came out as a kind of forking from an ecosystem where they didn't like the constraints of Sun and of the Unix ecosystem, so they decided to invent their own, and now Linux is dominating absolutely in all of the server deployments of the world. So the fact that sometimes something breaks the rules, forks, and builds something better can be positive. But 90% of the time it's better to come back.
And another example that I had similar to this is even like TypeScript itself, right? We had JavaScript, but at some point we decided, like as a community overall, that having types and having this additional thing on top of like JavaScript is worth enough for it to exist on its own, right? And before it existed, nobody know for sure, and we kind of had to try. And this is even interesting, taking into account how you are trying to build TS Plus right now, because you kind of said that it would be even more beneficial to have like additions to the TypeScript itself, right? In my opinion, I saw good things in terms of how you're trying to preserve backward compatibility with TypeScript, right? In a similar way how TypeScript tries to kind of be able to execute regular JavaScript, right? And it is good. In the case of TS Plus, right? I don't, to be honest myself, I don't know what the experiment kind of will end up being, right?
I don't know it myself.
It could, yeah, this is the point, is that it could, maybe it can become something, a thing that will have enough value, bring enough value for people, and it will kind of stay its own thing, right? Or maybe it can also be something like an experimental project, and good ideas from there will eventually find its way into like maybe JavaScript, TC39 specification and stuff like this, right? Or TypeScript. We will see, but it is good. This is exactly the point, that we need to experiment. We need to see how it goes, right? We need to put our best effort, right, into doing our experiments.
That is another perfect case of a software I've used for years without knowing the actual code base, TypeScript itself, and ending up forking TypeScript and having to learn files long, like there is a file called the checker.ts inside the TypeScript compiler that is 45,000 lines of code, of highly mutable nested code. Understanding that was kind of completely insane, but it has been a fun experience. And I ended up implementing the features that I wanted to implement. I think TS Plus in its own is not a project that will be important for the many in general, because there are limitations on the speed, the completion speed. TypeScript is slow in itself. And for many people using it in front end, the feedback cycle is too slow. And there is absolutely no way of optimizing it. To optimize it within the TypeScript code base. You could build another language, but that's another discussion. The current limitations make it not viable for many, and the design decisions of many build tools such as SWC, ESBuild, Babel, and so on and so forth are not allowing type checking to happen upfront and code generation to happen after. So TS Plus is kind of limited to a small set of users. But I actually care about TS Plus for two different reasons. One is building libraries, because building libraries does not have the same constraints as building a front-end application. You don't really care about the iteration, the feedback loop. Like if you save a file and it compiles in 3 seconds or in 5, doesn't change much for a library. Changes much on code where you have like to change styling of an interface and you want to iterate 500 times per second. Okay, you add 1 pixel, less 1 pixel, plus 2, minus 2. Okay, that's okay, change 5, and so on and so forth. For that use case, it's not good, but for the library use case, it's good. And the other one, which I believe can become some sort of useful for most, that you have used the IOTS. So you are familiar with the codec definitions and
Yes,
the
yes.
idea of generally defining types using those libraries that allows you to do proper serialization and deserialization with checking of data at the edge. It's very noisy to write those things manually. And you would really like to have what other languages have, which is, for example, you define a type, so like an interface instead of an IOTS codec, and the IOTS codec is derived for you from the compiler, so you don't have to write it manually. Like an IOTS codec, you could derive an equality, you could derive a partial order, you could derive a debug instance, you could derive a hashing instance. There are many things that you can derive. And there are languages like Rust, like Haskell, like Scala, where this is native. Well, in TS Plus, we can do that. And on your data model, you don't iterate as fast as on an interface. So like in a project that is using TypeScript for 90% of the things, it can still use TS Plus for that 10% that is data modeling and derivation of codecs from pure types. For that aspect, I think it's so useful to be able to say, okay, derive me an IOTS codec for this type that I already have defined. Derive me an instance of equal for this type that I already have. That aspect might end up being useful for many. But you pointed out experimentation is where everything starts. I'm even experimenting with building a new language from scratch. Never built a language, but I'm curious. Now that I've seen a compiler, I'm curious to see what could I do in implementing a new language. Nobody knows where it's gonna go, myself too. But to get to the next level of things, you need to experiment. You need to test your limits, to test your assumptions, and you can do so only if you are crazy enough, like you said, to build a bicycle by yourself and try to use it. Now, of course, you also pointed out that it's not good if you try to build a bicycle in production. I would disadvise everybody to build a bicycle and a complete company over the bicycle before making sure the bicycle works. But you gotta build bicycles.
Yeah, that's true. One thing I wanted to ask you, I mean, a little bit more also abstract question, but in general, in how you kind of approach the things you're doing, do you find yourself more often kind of writing code in front of computer and experimenting with it, or more thinking about it? Like, can you do a significant amount of progress in terms of just thinking pure even without computer, or it is not as common in your like day-to-day habits?
I can go months without writing a single line of code.
Yeah,
Most of the innovation happens inside here. But whenever I reach a conclusion, like, for example, the new language that I'm trying to build, it's a lot inspired by TypeScript, clearly, and it takes inspiration from other languages like Rust and Scala. But to even start, I had to come up with a design that I think will be better. Coming up with the design is not something you do while typing on a keyboard. It's something you do uh, with your mind, thinking about how it might look, thinking about how you could implement it, thinking about the architecture of the compiler and so on and so forth. Only when you get to the point of having an idea, then I want to test the idea. When I'm in proving assumptions phase, then I go deep code. Like then I start coding like 10, 15 hours per day even. So I could go months without coding and months coding 15 hours per day. That obviously works only in if you are building libraries, if you are building open source software, if you are building those abstract things. I wouldn't see the same approach working on if you have to build a product in an everyday. There you have to be more lean and mean, kind of compromising, finding progressive compromises and switch more. I mean, you still have to think before writing 100%, but you can't afford thinking for 2 months before writing.
Yeah. Yeah, that's true. I mean, I personally, it's just what I'm interested in, and I find myself kind of my interest in all those things that we talked about first comes from the desire to build an end product, right, for the users. And in my case, it is usually people who use their phone or laptop, right? It's not my users are not developers usually, right? And for this, I try to always come from real problems, right? And yeah, I try to kind of find a balance between doing actual features which are helpful and at the same time increasing the quality of the technical aspects, right? And it is hard to do that, and I'm not there is improvements for me in terms of finding this balance, right? But yeah,
Yeah, but
but
even there,
sometimes
it's very
yeah,
important to do both, because otherwise you get to
yeah,
the point where adding a new feature is way too expensive for you because you're paying the whole cumulative tech debt that you have on the whole project.
yeah,
Cleaning up the mess is fundamental. Now you can't
yes,
like a decent amount, a manageable amount of debt. Usually it's called technical debt because there's a
yeah,
parallelism with actual debt, with actual
yeah,
leverage. Now, if you wait till the point you have all the money to buy a house in cash, you lose a lot of time. You might as well get a mortgage as long as the interest rate and the monthly payment are manageable for you. It's a boost on the long term thing because otherwise every month you pay rent. Now I don't own a house yet, so I'm paying rent. In this example, I'm the dumb
so
one. But the parallelism is this: a good strategy of managing technological debt is fundamental for a good outcome of a product. And even like it's not only a balance between the two, but you also asked before how much time you spend non-programming. Like in product land, I see a lot of companies building features directly. Have a chat with your customers before, with your potential customers before you build a feature. Test if they even want that feature. You don't need everything done before testing the assumptions. Otherwise, you end up programming for years and building something that nobody will ever use because it doesn't might make sense for you, but makes sense for nobody else. It's way better to like partially speak with your customers, then think about the product features you want to add, then go back to the customers. And only when you realize, okay, this is actually what I want to build it. Like building it should be the last thing you do. It should not be the first thing you do. If you first build it and then show it, you're gonna get it wrong 99% of the time. And this is a hard lesson I've learned myself. I mean, I failed company for this reason. So
yeah. It happens to the best of us, let's say.
it happens to everybody. Come on. I don't know a single entrepreneur that has never failed.
Yeah, that's true actually, and I mean it is helpful. And the problem is that this balance that we talk about, nobody really knows where is the line that you need to draw, right? It is very it is always very subjective, right? And I do believe that it is important for people to kind of understand and have sufficient courage to make the calls when the calls needs to be made, right? But also have some humility to understand that they could be wrong, right? And this is how I try to approach things. I don't want to kind of put the decision making on someone else, right? Just because I don't want to make a call and get it wrong, right? But at the same time, I always try to be on the lookout to analyze things if what I'm doing is not productive anymore and something needs to change, right? It's kind of, and it's good. I can talk very eloquently about all of the things, but the important thing is that reality will show whether my approach was good or not in like 4 years. We'll see. I don't know for now. Yeah, I think since like I also wanted we talked about a lot about like engineering, right? But I think one of the last things I wanted to kind of ask you, because you and I and other people all found functional programming to be useful because it allowed them to do things more productively in their life, whatever they want to do, right? Have a better result, do it in in a smaller amount of time. Do you have you found any other things in your life, maybe outside of programming, that also kind of you found very, very important for your productivity, but not many people kind of realize or do them? If you could like talk about one maybe example, if you have.
That is an awesome question. I think, yes, there is an important one thing that actually links to something that I deeply care about. And I think from some of the words you've said in the last few sentences, I think we're both kind of passionate about the word of education and the word of, well, learning in general. I find it that many people goes to universities with the idea that a university should lead to a specific job. They have the expectation that by having a degree, by getting a degree, no matter what they actually learn during the degree, that leads to something. And that degree is an absolute requirement for everything you want to do. That is a misconception that has blocked many, many friends of mine, that I find them constantly then calling more recently, asking, how can I enter the job market? I have a PhD. And I'm like, yeah, and what do you want to do? I have a PhD. And it's a Ouroboros. If you know what a Ouroboros is, it's this snake that ends up eating itself. I think one of the best productivity boosts in life that I found was approaching my university time in a way that I was trying to maximize what I wanted to learn for passions I had. I was passionate about finance. I was passionate about mathematics. I already know lots of programming and code because I've been programming since I was 13. So I couldn't care less about following some like programming courses in university. That to me was totally irrelevant. I wanted to learn the bits of mathematics, but bits of actual mathematics, like a mathematician does it. I'm by far not at the level of any PhD in mathematics, but I know my way around a paper. If I want to actually go deep in any of the topics of mathematics, I can go deep. Doesn't mean they come like that. I may have to spend months and months and months trying to understand the topics, but I have enough base knowledge where I'm sure about my way around. Then I took a little bit of finance because I was passionate about finance. It's not that everybody has to do the same, but if you want a specific job where the degree is actually heavily required, first, be very sure that you actually want to do that job. Second, go and finish the full degree, get graduated, and everything else. If what you want to do doesn't really need a degree, and for example, software development, I have never been asked for a degree. I have never asked anybody for a degree. And if I see a job posting where degree is required, I am 100% sure it's not a company I want to work in because they understood nothing about what software development is about. So the productivity boost, which is totally unrelated to software development, was approaching the university in a way where I actually got what I wanted out of the university, and I have lost 0 days of my life in things that I didn't care about at all. It's like a filter for things that you don't care. If you don't care, probably you're never gonna do it. If you don't care, it's not for you. Don't spend times doing things you don't care about. That's the hard realization that not many that I know have done.
From my side, I actually started. I was studying in a college, right? And then I started to work in an industry. I got my job even before I joined a university. I started work, and maybe in a half a year I got in a university. And it is very my subjective experience, and it is very specific to the place where I was born and I was studying. But those things were in parallel for me. I learned like a huge amount doing actual work than doing it in university, unfortunately. But I'm glad. I'm glad that in my life it just happened that I joined, like, because I could wait it like 4 years and only after that join. But what I did, I actually joined like even before, and it was very helpful for me. And what is even more interesting is that right now, as I continue learning and as I have the same amount of interest in terms of general to the knowledge, right? It helps me a lot. Understanding that you can learn by yourself without someone teaching you, it helps a lot. For example, I have so much appreciation, for example, to the content that you can find online, even from the top universities like Stanford, MIT, and stuff like this. And I am thinking like, okay, these people pay like 40,000 a year, and I pay zero right now.
One day pay more, but they pay for the degree. They don't pay for those actual courses.
Yes. I understand. They pay for credential as well, and for the ability to kind of ask a question right there and then if you don't understand something to some extent. But credential is the most important thing. I agree with you.
But
Right.
to ask questions,
still,
there is also Twitter. Like, you can literally go to Twitter and ask questions. You'll find somebody that answers you with, yeah, light went off.
Okay, yeah, I think it is time to wrap up it in some sense, because the technology is giving up. We we continue strong, but technology is struggling. Okay, first of all, thank you a lot for kind of dedicating your attention to me and giving this opportunity to have a conversation with you. We for sure could talk like a lot longer. This is true from my side, for sure. I hope the same is from you as well, and hopefully we will at some point, if you find it interesting, we can do it again at some point.
Absolutely.
But we will learn a lot by that point as well, for sure. And I do appreciate you sharing the things that you the most interested in, and the things that help you a lot with me and with others as well, so we can all kind of benefit it. And your whatever you have learned over the course of your life, it also helps not only you but a broader community, which is helpful, in my opinion.
And I have to say, it's been a pleasure to be here. I know this podcast is very new. You're working your way into an idea you have. I wish you all the best for the outcome of this podcast. The conversation was pleasant by any mean. I had fun being here, and I gladly return whenever you want. I hope you have many productive conversations with many people that you enjoy, that you extract as much as possible from many different minds in the world. I think you are on the right track to do that. Not because you invited me. That might be a bad choice, but because you're trying to do it. And again, thank you very much for the invite, and it's been a pleasure to be here.
Thank you.